Hello, everybody. Hi, my name's Iñaki. I'm a solutions architect at NVIDIA. I partner with Vultr a lot for a lot of the bring up and helping out other customers of theirs. Um, you know, and so today we're going to talk about NIM Operator. Has anybody heard of NIM Operator before? He has, great. Because he heard it last time. So NIM operator, so essentially NVIDIA has these inference containers called NIMs. Basically, sure, anybody wants to deploy all these different open source models. Everybody has a different way of doing it. Sure, there's VLLM, there's other things like that, but how do you go and deploy that in a production-like manner, right? There's, of course, a lot of open source options, but if you just want to deploy it on Kubernetes, how do you do that, right? So NIM operator is that tool to do that, so we're going to go through that. So, of course, as I said, there's a lot of different um, challenges with when you're trying to deploy AI models, and even like the open source ones that are supposed to be the easiest to deploy. Um, and ensuring that that is auto-scalable, has metrics behind it, and is supported by some sort of enterprise support agreement, things like that, so your customers can rent from you and use your endpoints with confidence, right? And then of course performance is a really big thing. Workflows and auto-scaling with quick performance is necessary. And so there's a bunch of different NIMs for all these different domains, right? And so at NVIDIA, we made speech NIMs, RAG NIMs, visual ones, healthcare-centric ones, and at NVIDIA, all these different teams, right? They're creating foundation models for all these different things, and sometimes they don't all use the same acceleration libraries, right? So of course, TensorRT-LLM is specific for large language models, but that won't apply to a healthcare use case or a computer vision use case all the time, unless of course it's like a multimodal model, right? And so all these engineering teams were kind of making their own way of deploying these things, and everybody was creating their best way to deploy inference way. And so then we decided that, oh, we need to come up with a centralized way to deploy all of these different containers. We need to agree on a OpenAI endpoint style, and then all agree on metrics that we can use to auto-scale, right? So that's when we introduced the NIM operator. So the NIM operator, it allows to do lifecycle management of NIM at scale. So, and it just requires Kubernetes under the hood and a storage backend, right? It does a lot of pre-caching logic, and we'll go all through of how easy it is to set this up. It supports standard Kubernetes distros. It's supported by NVIDIA AI Enterprise, which is NVIDIA's AI Enterprise software suite that is supported. It's open source as well, and yeah, it's been out for a long time. There's actually quite a lot of features that have been implemented since then. So the high level architecture here is there's the idea of a pipeline and a service and a cache, right? So the pipeline allows you to create a lot of different services, which are just kind of your AI model, right? So you can pipeline a bunch of different ones together. So kind of the killer use case for this is to use an embedding model with a large language model or RAG adapt, LoRa, etc. Right? And then those deploy individual services, and it's all one Helm chart, Kubernetes manifest, and it all can be deployed at the same time, and then copy paste to throughout your Kubernetes cluster. The model cache controller allows you to cache that large language model profile. So the whole point of NIMs, right, is that when you start a NIM container, it will look at the GPU that you have that you want to deploy your model on, and it'll look to the NVIDIA cloud to see which model profile that has already been generated with TensorRT-LLM. One of the biggest criticisms of TensorRT-LLM is that it's kind of hard to use out of the box sometimes, right? And that's why we generate NIM model profiles that are already the most optimized configs for that specific GPU, right? So for instance, a Llama 7dB model, you want to go deploy it on an H100, there's a latency optimized model profile. There is a throughput optimized model profile, right? And then you can just turn around and deploy that same exact container on B200 tomorrow, right? And it'll download that optimized model profile, right? And so you want to cache those models because then when you start up another instance of the NIM container, you don't have to re-download that model profile again, right? So we're going to go through a really, really quick tutorial here, and you'll see how easy it is. You can go from just having a raw Kubernetes cluster on Vultr to deploying and being able to query a model endpoint in about 10 to 15 minutes, depending on your model. And if you're experienced, it's 5 minutes. So we started with an A100 Vultr instance on Vultr Kubernetes Engine. And we have, like, of course, backend storage, and so we're using Vultr's storage provisioner backend in this example. You have access to the NIM containers as well. Sorry for all the code, but you go through all of your, you set up your, like, the NIM operator, CRD, you install the Helm chart, you set up some credentials and whatnot. Then this is how you create the cache, right? So we're creating secrets, and then here is the actual manifest, and this is, of course, all documented in, like, the, on the docs and for NIM operator. So see, we're pulling that in that model puller section in the middle. We're pulling the Llama 3.1 AP instruct model, and then we're saying that we'd like to do a VLLM profile with tensor parallelism of 1. So and then it'll automatically detect that we have an A100 when it goes to pull the model, and it will download the VLLM tensor parallelism 1 model profile from NGC and cache it in that Vultr block storage that we have there, right? And so then, like I just said all that. So it'll auto-detect GPU type, download the model profile from NGC. It also has support for both VLLM profiles and TRT LLM profiles, as well as LoRa adapters that can come with those as well. And then it'll store that model profile in a persistent volume. Then going forward, this is the manifest that is required to deploy a NIM operator model. And so if you see on the, like, halfway down on the left side, we're using that NIM cache storage that I just got, and it's a VLLM profile in BF16 with tensor parallelism 1. And then you're just gonna, and then I set up some ingress stuff on the right so that we can query it, and then we're requesting 1 GPU from our cluster. And then you go and you apply this YAML, and then I just did a port forward as a workaround for not having my own load balancer. And then we're able to, and it'll come up in about 2 minutes, 1 minute maybe. But because we cache that model, it can take like 30 seconds or less. And now we have that model deployed on our Kubernetes cluster, and we can query it, and we get that result right away. Yeah, and so, like, of course, full disclosure, this presentation is like not brand new. So a lot of things have happened since then. Like, there's a whole lot more pipelining logic added to NIM operator that allows you to do more complex agentic workflows and things like that. Having multiple, like, NIM services work together, do embedding, do, like, LoRa adaptation, things like that. It's much more advanced now, and it just works out of the box on Kubernetes. Like they gave me a Kubernetes cluster, and I was able to just get it up in like 15 minutes or so, with not a lot of headache. Yeah. Any questions?
Do you support the multi-model serving as well, or is it just primarily for a single model endpoint per pod?
You said.
Is it primarily for a single model per endpoint per pod? I mean, per GPU.
So the question is about, like, having multiple model endpoints per pod.
Yes.
I believe that is so that would be not a limitation of NIM operator. That would be a limitation of, like, NIM. And so yes, I believe that NIM now supports multiple model endpoints per pod. Yeah, and I think there's 2 or 3 available now, depending on, like, what you want to do with it. But yeah.
If it does support, then there's going to come with a tight cold start. So that's
one more time, please.
If it does support the multi-model serving, it has to come with a tight cold start, right? So for when you're switching the models.
It depends on the. So the question is, like, if it does have multiple endpoints, it has to have a pretty optimized, because you have to unload and load models. So I think I'm going to counter that and say that the way that NIMs are designed, they're actually, like, engineered for performance rather than capacity, right? So like, you're not going, like, a lot of NIM profiles aren't, like, running right up on that VRAM barrier. They're optimized for performance, and so therefore you can just load both of those models usually, right?
Thank you.
Yeah. Mm-hmm. Any other questions? Great. Thank you.